Hi guys, so in this video what we're going to do is going to look at what's called arrangements, otherwise known as permutations. So the quick question for you here, it says how many different ways can you arrange the letters A, B, C, and I want you to list them. So think if you had 3 people and 3 different chairs, how many different ways could you arrange Adam, Ben? So the way to do this is just by brute force, that's what I want you to do. So we have A, B, C is one way we could list them. We've got another way, which is A, C, B. The second way we could list them is B, A, C, and B, C, A. And lastly, we can do C, A, B, and C, B, A. And notice I've done that quite systematically so I don't miss one. You can see here the 6 different ways that we can arrange 3 different people. Now there's actually an easy way to do this if we use the whole idea of the box method that we've been using in the previous video. So let's set it up as a box method, and what we have here is for the first choice we have 3 choices. We can have A, B or C, so we get 3 different choices that we can have for the first position. Well, if I just write them up here, A, B, C, if I choose one of them, that means now I'm left with 2 choices, so 2, that's B or C, and I'm going to choose one of them, which now means I'm left with just C, which is 1 choice, so we end up with 3 times 2 times 1. Now if I look at A, B, C, D here, we've got exactly the same sort of idea, apart from for our first box, we don't have a choice of 3, we've got a choice of 4, and so on and so forth. So let me just draw the boxes in, 1, 2, 3, 4 boxes there. So for the first box I have a total of 4 possible choices, then followed by 3 because I've already chosen one, then 2, then 1. So I end up with 4 times 3 times 2 times 1, which is, remember we said that one was equal to 6, and this one is equal to 24. Again, if I wanted A, B, C, D, E, instead of 4 times 3 times 2 times 1, I'd have 5 times 4 times 3 times 2 times 1. And this is a very special thing that happens in maths, and it happens a lot. So it has its own symbol. So what we can say is that 3 times 2 times 1 is otherwise known as 3 factorial. It's a little exclamation mark on your calculator. 4 factorial would be 4 times 3 times 2 times 1. And if you have a look at n factorial, where n is any number, you can see what we're doing is we're starting with that number, and then we're going down by 1, and multiplying it by another 1 there, and that goes all the way down to 1 at the end there. So, for example, if my n is equal to 10 here, it'd be 10 by 9, because 10 minus 1 is 9, by 8, by 7, by 6, and all the way down to 1. I've just explained this on the other slide here, so that's what we showed there, that for example 3 factorial was 3 times 2 times 1, etc. And what we have here now is how many arrangements are possible of all the letters of the word Sunday. So again, what I do is if I write out 6 letters here, so there's 6 of them, you can see that I have 6 possible letters for my first box. So I've got 6 by 5 by 4 by 3 by 2 by 1. So this is 6 by 4 by 3 by 2 by 1, which is equal to 6 factorial. And if you stick that into your calculator, 6 factorial is 720. That's part I done. That wasn't really that interesting. Let's see if we can get one that's a bit more interesting. So just how many of these arrangements start with the letter S? So let's keep going with the box method, guys. I really like this method. I think it's very difficult to go wrong if you use the box method. So it's a bit like the problem we had in the other lesson that we did, the previous one to this, and it says it has to start with an S. So this one here has to be an S. So we only have one choice. It has to be an S. So the only choice we have is the S. So we can only put one of the letters there. That now means that there are no other sort of restrictions. So that means that I now have 5 left to choose from, 4, 3, 2 and 1 as before, and you can see this is going to be just 1 times 5 factorial, and that's essentially 5 factorial, and 5 factorial is 120. Let's look at the third one. So how many arrangements start with an S and end with a Y? So we've got the same sort of problem as part 2 here, apart from we have 2 restrictions, which is fine. So let's just put the S here, let's put the Y here. And you can see, so that means that we have one choice for this box, it has to be an S. And we also have one choice with this box, that has to be a Y. Which means now we've used 2 of the letters. Which means there are now, for this box, 4 left, 3 for this one, 2 and 1. And hopefully you can see that this is 1 times 1 times 4 factorial. And 4 factorial is equal to 24. Okay. Again, same sort of idea. Now this is an interesting one. So it says how many arrangements are possible of all the letters of the word Ukraine. Now you can see here, let's just do it again as we've been doing it, the box method. So we have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, perfect. And as before, what we have, there are no restrictions. So what we can do is say, well, 7, 6, 5, 4, 3, 2, 1, 7 factorial, like it was before, so that's just a really bog standard one. And if we do that, stick it in your calculator, it's 5,040. Okay, now how do we do with all the 4 vowels appearing side by side? Okay, so I'm going to use near enough the same method. So what I'm going to do is I'm going to make a super tile. Okay, so this super tile has U, A, I and E in it. And that means that I've got the other 3 tiles, the ones could be possible, so I could have K, R and N. So we know that these 4 tiles have to be next to each other. So I put them into a big super tile, which means that there's the other 3 tiles, or the other 3 boxes that are here. Now, what I want to be able to do is I want to be able to move these around. So, for example, I could put U, A, I, E, and I could put R, N, and K. And I can move the R to here, or the R to here, or the K to here, or the K to here. So what we essentially have is we have 4 boxes that we're trying to move around. So you can see here, there's 4 boxes that we're trying to move around here. There's 4 factorial ways of selecting these 4 tiles here. Okay, so that 4 factorial will make sure that we have these in all the orders that we need to do. Now, it also means that we can change the order of these, because it just says that the vowels have to appear side by side. So it could be U, A, I, E, it could be U, I, A, E, and so on and so forth. And we've already done this because we did it with A, B, C, D. Which means that what we have again is that we have 4 factorial ways of changing around the 4 vowels in this super tile. So that means altogether we have 4 factorial times 4 factorial, and 4 factorial is 24. So 24 times 24, and that's equal to 576 different ways of arranging them with 4 vowels side by side. Hopefully this makes sense, and have a go at the exercise.